I'm presenting a digital twin of a natural asset. I realized that is slightly different, maybe from the previous applications that that have been presented in this session. So in this presentation, I briefly want to set out the actual project that we built the digital twin for, why we would want to use digital twin in coastal management, and then I'll go into a bit more depth about the actual beach twin. So this digital twin was built for the Beckton Sandscaping scheme. That is a coastal management scheme along the North Norfolk coastline, at the location of Beckton. Beckton has a gas terminal that is critically important for the gas supply to the UK. 30% of the UK demand comes in by Beckton, and therefore, if something were to happen to that terminal, that would cause big problems. This coastline, which is cliffed where the terminal is receding, is losing sand, and therefore the cliffs are attacked by waves, and the cliffs are crumbling as well, which threatens the terminal's infrastructure. Now, additionally, along this coast, we've got a few smaller communities, Beckton, Walcott, and they are at risk as well from coastal erosion. There is a seawall, but due to coastal policy in the UK, that seawall is not likely to be reinforced in future, and so these communities need to look at adaptation of their communities to cope with coastal change and with the receding coastline. Now, the gas terminal, of course, was looking for a solution to this threat because to prevent the gas terminal from being impacted by coastal change. And the obvious solution would be a solution made of hard rock, placed in front of the terminal to limit the impact on the cliffs. But unfortunately, that would have led to an increased impact on the downdrift villages because of the sediment not entering the system at the terminal. It would have advanced the erosion of the beach even further at the villages, and therefore that wasn't really a viable option. So this was kind of an unsolvable project until we started looking at soft solutions. And so in the end, we ended up placing 1.8 million cubic meters of sand on the beach. That is, if you imagine, that's more than a Wembley Stadium filled with sand. And we exported actually a Dutch innovation. You can see it in the upper image. That is the Zandpoter in the Netherlands. Much larger scale even than what we did, but it's meant to protect the entire Dutch coast, and waves and tides redistribute the sediment that you see in the picture along the whole Dutch coastline. So we work with nature to solve this problem, and we kind of did the same in Beckton and Walcott, which you can see on the right, of the lower right image. And we placed a bulk of sediment in front of the terminal, whilst also broadening the beaches in front of the villages. And over the years, it is expected that bulk of sediment in front of the terminal will be spread by waves and tides towards the villages. Now, it gives a very high level of protection in front of the terminal. We don't need to go back there for another 15 to 20 years to actually do something with that beach. That should be protected. And at the villages, they've got higher beaches, slower erosion, which makes for more recreation and other benefits, and gives them time for adaptation. These are some images from the terminal location. You can see the impact that the scheme has had there, and we placed sediment up to about 7 meters. So it's quite big. And this is the impact it had at the villages. The house in the pink circle is the same, and the upper image is before the scheme, and the lower image after the scheme. And these people actually told us we were able to sleep now. We know we're safe. So a digital twin in coastal management is not very common. but we're talking about a natural asset here, and that means there's a lot of variability. That means there will be a lot of monitoring. We want to quantify the uncertainty also after we've built it. And because we're doing adaptive asset management, it suits itself for a digital twin. That digital twin can be driven by data that is relevant and suitable, and I've kind of coined the term right time data here instead of real time data, mainly because for the particular problem that we were looking at, 10 hertz sensors wouldn't have added any value. We're looking at 15 to 20 years lifetime, and therefore real time means something completely different in that context. But I'll get into that in a minute. Such a digital twin can create insight into future behavior, especially if linked with coastal modeling that was already done in the design of the scheme. And our goal with this digital twin was actually to improve future decision making along this coastline by increasing the knowledge about the processes that are taking place, and by decreasing the uncertainty towards what the future behavior of the scheme. And the digital twin we built for Beckton is aimed to answer the big asset management question that the client group had. So that was a private and public combination. And they basically just wanted to know, when do we need to reinvest into this coastline? When do we need to start planning? When is the scheme completely spread out? When is the beach state critical, and when are our assets at such a risk that we need to reinvest? So what we've done is so this is an artist expression. I will show you the actual digital twin interface in a later slide, but from the design and literally just after implementation, we had a topography and bathymetry data set, which is basically a digital elevation model. So what we do in digital beach twin is we update this DEM with data using innovative survey techniques. We can get a data set from the cliff top to about -12 under mean sea level, and we have done that about every 6 months. With that data, we update the coastal model, so it's a physics-based model, and we update that with the data that we've got to increase to decrease the uncertainty, to increase the accuracy, using actual hydrodynamics that have been measured along this coastline. And then we rerun that coastal model to update the future prediction of the coastline. And what we've done is we've defined critical beach states that form a trigger for intervention. So basically said, if for example a certain amount of volume of sediment is left, then your risk is that high that you need to have put an intervention in place. And we've defined those beach states, and by comparing them to the coastal modeling, we can actually say to our client group, we can give them a prediction of when and where they're most likely to intervene. So we capture data of the physical world, and that's those highly accurate regular beach surveys, about every 6 months. We use that to describe the physical world in our digital twin. We do that by and then update the numerical model. We use the numerical model to predict the future physical world and the coastline over the next 40 years. And we then use those critical beach states to define when an intervention would be needed. So we prescribe that to the client, and they can then make their investment decisions that will hopefully lead to an increased resilience of this particular coastline. This is what the tool looks like. This is the online user interface. Now, this is coupled with a backend that as a coastal consultant, because I'm not a I'm not a software designer. I'm not a programmer. I'm a coastal expert. This is a backend that I can use that helps me to convert all the data that comes in into something that the client can see on its screen. It helps me to recalibrate that model and to rerun that model into the future. So we haven't included any machine learning in here. That in our field, that is not extremely far developed. I still have to do the work, but this makes it a lot easier and a lot faster. And it gives the client an online portal that they can actually see the information in that they need to see. It shows them what the past, present, and future state of the beach is. It shows them in more detail in cross sections how the beach developed over all the data that we have. And then we use those trigger states and model results, which are also displayed in here. We actually slow them in a long-short direction for each cross section when they're expected to intervene. We've developed this overview in very close collaboration with the clients, so this is exactly what they need to inform their investment discussions. So I did want to show some lessons learned in this presentation. Some success factors where we worked in very close collaboration with our client group. Like I said, is exactly what they wanted to see, what they needed, and that created buy-in from them. We did a few user sessions in which they got to play with the tool whilst it was still in development, and that was really useful. We focused on supporting their decision-making framework of their decision-making, and digital twin is part of a framework. It's not an non-objective itself, but the digital twin is a wrapper around their management question and their need, rather than just being a tool. But actually, it does serve a very clear purpose. When do we need to reintervene the coast? Digital twin tells them that. And consultancy meets digital was a big thing here. Within our organization, we've got a separate digital business line. I sit in the maritime and coastal part, and we were as a consultant, I work closely together with our software programmers to make this a success. There are some limiting factors. Clients need to understand their management questions first, or a management framework first, before they can actually ask us to build a digital twin. We can help them with that, but without a clear management question, it's in my opinion very difficult to build a digital twin for asset management like this. We are still looking for ways to scale this up, and for clients, it can be daunting to justify finding the funding for this, especially because we work a lot for local councils, for municipalities, and we have shown now for this example that actually in the long term it's more cost effective, for example. But this is an issue when talking with clients. You could also apply this concept, in my opinion, to other natural assets. It's a versatile concept as it is built around that management question. There are a few requirements. It needs to be a managed asset, a managed natural asset. You need to have suitable monitoring data. Now, as I said before, that doesn't have to be real time in the sense of 10 hertz, but it needs to match with the timescales that you're looking at in terms of your management. And of course, there needs to be an element of future predictions versus a trigger that triggers some action. And we've applied it now to a beach, and to coastal protection. But there is, of course, much more wider potential than that. You can also think about recreation, about habitat management, etc. And I think I'd like to leave it there. Thank you all for your attention.